So my name is Timothy Laurent. I'm a student in Georgia Institute of Technology's OMSCS program, and this is my project, IE Reader, an assistive technology to promote reading comprehension that was done for the educational technology course CS 6460 in the spring of 2019. IE Reader his goal is to harness natural language processing models to do open information extraction of textual content, and then use other models, coreference models, and heuristics to normalize the entities, and then to build and create, build and expose to the user a knowledge graph like visualization that captures the entities and the relationships represented in the text. The architecture I chose for this was a backend consisting of Python web server. Used Flask and GUnicorn for its simplicity, um, and used the Spacey NLP program or software for doing basic textual processing, stop word removal, sentence iteration, and then used two models from the Allen NLP library. One of them is an open information extraction model. This model came out this year or last year in 2018. And it uses bidirectional LTSM. So we can see over here on the right. Oh, you see over here on the right the inputs to the model. It creates a embedding model of the part of speech and the word embedding for each word in the sequence. Feeds those into a bidirectional LSTM model. It's a long-term, short-term memory recurrent neural network, and then predicts the probability of each token being the beginning of, the beginning, the verb, or for each argument of a subject verb predicate argument. So we can see here in the paper that this model achieved quite good improvement over previous state of the art Clause IE, which was a more rule based open IE approach that I also tried, that used more regular expressions and rule based logic. It exceeded it in three. It had partial wins in these two data sets, but it achieved state of the art in quite a few of these NLP tasks. And here is a quick visualization on Allen NLP's website of them using it to show the verb and arguments in this one sentence. The coreference resolution model was also a model from the Allen NLP suite. It was from a study from Lee and Kenton et al., end-to-end neural coreference resolution. And with this approach, they combine a word and character embedding for each word, and then using a bidirectional LSTM with an attention mechanism to create a mention score for each span representation. They then have another feed-forward neural network, not shown here, that takes the spans and measures the the co-reference between each of the spans. And this was a supervised learning task, so they had a label training set that they could train the neural network to identify these co-referenced models. So you can see the results from their paper here, that their models achieved state-of-the-art across all of the co-reference tasks that they used it on. And here is an example of their visualization of their model. So we have Michael Cohen, and you see that they're matched up, and then we have Trump is matched up. So so yeah, this can also handle overlapping mentions. So for the front end, so and then I also did some heuristic merging. So when I initially ran these models and matched up by the coreference clusters, the graphs were still pretty disconnected. So use the heuristic of any span start with the same starting index would be merged, and that created a much more connected graph. And then introduced a Levenshtein distance metric to merge things, because I noticed some mentions that differ just by one being plural and one not, or a T cell versus the T cell weren't being merged. So I came up with a solution to remove all the stop words and then do Levenshtein distance, and that became a tunable parameter of the front end of the model. So on the front end, it was built with React, the Ant Design Library, which is Alibaba's design language, and they have a host of React components that are quite nice. Jed Watten's superb React Select for doing selection. Viz.js's network visualization library, and then the whole application was built with Docker and then packaged for deployment and development with Docker Compose. So in order to measure the effectiveness of this intervention, I performed some user studies. So I went to the SQUAD dataset, the Stanford Question and Answer dataset, version 2, and I selected a question about the immune system. And here is the passage here: when the T cell encounters a foreign pathogen, it extends the vitamin D receptor. This essentially is a signaling device that allows the T cell to bind to the active form of vitamin D, the steroid hormone calcitriol. T cells have a symbiotic relationship with vitamin D. Not only does the T cell extend a vitamin D receptor, in essence asking to bind to the steroid hormone version of vitamin D, calcitriol, but the T cell expresses the gene CYP27B1, which is the gene responsible for converting the pre-hormone version of vitamin D, calcidiol, to the steroid hormone version, calcitriol. Only after binding to the calcitriol can the T cells perform their intended function. Other immune cells that are known to express CYP27B1 and thus activate vitamin D calcidiol are dendritic cells, keratinocytes, and macrophages. So this was the question that I chose from the SQUAD dataset, and here are the specific questions. So some of these don't have answers, like what cell binds to vitamin C. They don't talk about that in the passage, so the correct answer would be no answer. So there are 9 questions here, and then like what gene converts calcitriol to calcidiol, for example. And then there is a 5-point scale of rating how difficult the survey was and how engaged the user was. So this was the first condition, and I administered this on Mechanical Turk with a script that prevented an individual user from participating in more than one uh, one version of the script. So each user should have been unique. I did find evidence that sometimes people had logged in with several different accounts and had the exact same answers. So here was that we just looked at version 1 of the quiz. Here's version 2. It has the text, and this text is also an image, so you can't just select text from it. I noticed that was happening in a pilot study, so I turned it into an image just to make it a little bit more difficult. So here you can see the graphical output of IE Reader. So it's a signaling pathway. We have a node here for T cell bind. So this is, for T cell. It was difficult to come up with a good string representation of the nodes because the arguments would kind of grow. So I believe it or not, there was a good deal of culling of extraneous information, but it still was pretty long and could use some work there. So you have a T cell encounters a foreign pathogen, a T cell extends a vitamin D receptor, a T cell binds to the active form of vitamin D. They have a symbiotic relationship with vitamin D. They extend a vitamin D receptor. They express a gene. After binding calcitriol, and then talked about the other immune system cells. So basically, a lot of the information is being consolidated here and put into a graphical form that has meaning, and it can be used to answer some of the questions. Now, here's the third. The third condition was without any text and just the graph. Can they answer these same questions? So one thing to note initially is that there are issues with the string representation of the nodes, which kind of make it difficult to understand. And then there's also, this is a pretty big graph, and the viewport of Google Forms is somewhat narrow. It's only using about the middle half of the screen, it looks like. So, there's potential UI issues with this approach, especially on Mechanical Turk, where the users were only being paid 30 cents a task. It's a pretty significant task. So down here we can see the survey exception rate. So with just a text, 97% actually who started the survey finished it, and with text and graphics, 90.2% finished it. This isn't exactly, this is just a rejected. So some of these were because there were duplicate answers. So I'm not sure that this is really indicative of much fewer. I think this could have been attributed to one where I had to remove 3 duplicates. So these might have been essentially equal. But with the graph, 17, so only 57% of the people started it, finished it, and I was able to use the data. Over here we can see kind of the distribution of scores. These are box plots with a swarm plot, so you can see the individual scores. There are only 9 questions, so there's only 9 grades for the scores. There was essentially, I did some statistics, and there was no real statistically significant difference between these populations, other than the scores were lower in the graph only. That was statistically significant. But you can see that, on the whole, the range, there's a bigger distribution of scores in the text and graph in the middle here. And there's a lot more lower scores in the graph. Overall, people didn't feel like it was more difficult unless the whole text was taken away. Then it did tend to have more self-reported difficulty. and overall the engagement was good across the whole thing. So I think what this tells us is, it didn't show the graphical interface was, the way it was presented didn't actually add to people's comprehension. Although we can tell that the median score was just one under the median score for the texting graph, which was also just one under just for just text. So there was a whole lot of information present in the graph that the users were able to use to answer the test. Yeah, they did find it more difficult on the whole, though. So here's a screenshot of the user design of the UI design of the application. Here we have a model selection widget. It's a drop down. Right now there's only one model, but there is a place to add more in the application. Here is a drop down that contains links to pre-made demo texts that we can fill the text with. Here's the text box. You can paste in any text you'd like. And then here is an area to kind of customize the parameters of the model. So this is a Levenstein distance kind of slider widget, and you can change that to change how the metric that the node merger is using to merge the nodes, and this can lead to more compact graphs. So for some data sets, although some data sets it doesn't seem to matter. Okay, so let's take a look at the app. So this app can be run from the root directory with a simple Docker compose up. Okay, it's running. So now here we are. I'll refresh the application. We have the drop down. You can see there's only one model here, and then we'll do this different squad immune system. So this one's about inflammation, and we have useful tidbits over here. The symptoms of inflammation are redness, swelling, heat, and pain. That's interesting and useful. Inflammation is one of the first responses of the immune system to infection. It is produced by eicosanoids and cytokines. It produces fever and dilation of the blood vessels. Interesting stuff. Cytokines are released by injured or infected cells. That's great. So I hope interferons have antiviral effects, such as shutting down protein synthesis in host cells. So it's all useful and good information. I'm sure you could answer some questions with this projection. Here's a simpler text about maybe let's try this. I think I'm just zoomed in. Okay, so here's a New York Times article, or a portion of a New York Times article. We have Democrats. Mr. Barr is scheduled to come before Mr. Nadler's committee on Thursday. Mr. Barr was threatening to skip the session. This is pretty... there's definitely room for improvement with the string representation. Democrats revealed that Mr. Barr was threatening to skip the session. Mr. Nadler said, we have arrows going this way. So this is capturing complex, relationships between the language. I changed the Levenstein distance here, and you can see we have a much more connected graph now. We can pull it out. We can analyze again. So that's disconnected, and now we'll give it, maybe 20% Levenstein distance. This seems to work pretty well. All right, so it's more connected. Obviously the nodes could be better represented, um, but I think this shows some promise for capturing some pretty complex information. Um, we can look at a news article about China. We have a lot of graphical nodes coming out. Chinese superblocks are comprised of many identical residential towers. They do not necessarily sort people according. So it's definitely a promising approach. I feel like. Um, so um, so let's talk about some room for improvement for next steps. So I think improved entity merging. Right now we're using heuristics. I think we could do better. I think we could use more information about the parse tree, or potentially using some knowledge based or distance supervision to identify nodes that are referring to the same thing and to merge them. A better node representation. Right now I'm just concatenating my attempt at deduplicating, partial sequences. I think we could do better. I think we could have, a canonical noun representation. But, it'd be nice to have some user studies to see what works the best. It would be great to add some two-way hover and click connection between the text and the graph. Um, I think that would really add to being able to connect what's in the graph with what's in the text. And then adding external information like Wikipedia data, this kind of goes back to the knowledge base. And then, potentially this could be used as an active learning framework where it shows you its best attempt at a, uh, knowledge graph. And then you could correct it and merge entities together or separate entities apart. And that could be used as material to train the graph. So, in conclusion, IE Reader it harnesses state-of-the-art deep learning NLP models and presents knowledge in a graphical format. And I think this could grow into a platform to develop better NLP-powered assistive technologies. Thank you for your attention.